Here is chapter 1.6. I don't want that. I want to make that wider that way. Extra practice. And this is going to be the video going through the main ideas for this chapter, which deals with absolute values. We have a traditional, it says solve the equation, then graph the solution or solutions. When we get an absolute value, we understand that this is a measure of distance, and that distance can be 8 away. So we understand that you can be negative away and positive away. So if we just saw this, if we just had a variable here, what number has a distance of 8? Well, -8 has a distance of 8, and 8 has a distance of 8. -8 is 8 away from 0, but it's to the left side, and +8 has a distance of 8, but it's to the right of 0. So we keep that concept in mind, and we are going to set the inside of the absolute value, because we want to know what value for y will make it equal, +2 will make it equal to 8. So we subtract, we're going to solve and isolate. So 6 would, if y equals 6, we would get 6 plus 2, and the absolute, which is 8, and the absolute value of 8 would be 8. What is the distance of 8? And then when we have y plus 2 equals -8, we'll subtract 2 from both sides, and we get -10. So if we plug -10 in, -10 plus 2 is -8, and the absolute value of -8 is also has a distance of 8. So these are my two solutions, and we always write them in a solution set, and then it wants us to graph it. So when we graph, we're never going to graph on there. It's such a, it's hard to see it. It doesn't really pop very much. So Mr. McCausland always graphs his solution above the number. Then we can see where it is, and it's a whole lot easier to decipher what information. So the two solutions to this first problem would be -10 and 6. Pretty straightforward. All right, number 2. Now we have a little bit more sophisticated stuff. 3x plus 12 equals 0, and 3x plus 12 equals -0. Well, we don't have to write this, because 0 and -0 are the same value. The only time we need to write it is when it's a non-zero, because then it would have some more distance. -12, 3x equals -12, divide by 3, divide by 3, x equals -4. Let's test it and check our answer. So if we plugged in a -4, we get -12 plus 12 equals 0. Absolute value of 0 is 0. So -4 is my solution. I'm going to graph it with a dot over -4. Perfect. We have our third question. Third question. Let's write, now, this is good. Now we see something is happening outside of the absolute value. So my first step is to isolate. We should always isolate the absolute value. We want to get it by itself. So we're going to subtract 2. We get the absolute value of 6 minus 5v equals -1. Oh, we should notice something, that this absolute value is going to equal a negative number. And what do we know about the absolute value of all numbers? That if we're measuring distance, it's always going to be a positive number. So this is impossible. There's no value that's going to come out of the absolute value that is going to be negative. These values are always going to be positive. So that situation will never happen. So my answer for number 3 is no solution. The thing that we need to remember is isolating the absolute value first. So we're going to isolate the absolute value because it's being multiplied by 4. We cannot distribute the negative 4. Cannot distribute into absolute values. That is not possible. So negative 4 is multiplying it, so we're going to isolate it in that manner. And we get negative 7/2. Now, what do we see again? We have an absolute value that equals a negative number. That's impossible. So we will say no solution for number 4 also. So that's back-to-back problems that provided us with no solution. All right, so 2 is multiplying it. Let's isolate it by dividing by 2. We have 0.2g plus 8 equals 5. That can happen. So since it can happen, let's write 2 situations. 0.2g plus 8 either equals 5 or 0.2g plus 8 equals negative 5. Let's solve for the variable. 0.2g equals negative 3. That's okay. That can happen. 0.2 divided by that, and we get g equals, what's that, negative 15, I think? And let's solve this one. 0.2g equals negative 13. Divide by 0.2, 0.2, and we get g equals negative 65, I think. So those are the 2 solutions. So we're going to put a dot over negative 65 and negative 15. And we get negative 65 comma negative 15 as my solution set. Okay, we could test those. We could plug them in and see. So 0.2 times negative 15 is 3 plus 8. No, it can't be 3. Did I make? Yeah, it's 3. 3 plus 8 is 11. Absolute value of 11. Oh, did Mr. Mac make a mistake? I think I made a mistake. Where did I make a mistake? That's negative 3. So 0.2 has 5. That's 15. Let's make sure 3 divided by 0.2 is 15. Yeah, that's good. So, really? 0.2, oh, 0.22 times 15, oh, hello, is 3. 3 plus 8 is 11 times 2. Oh no, I did that right. 11 times 2 is 22, but 22 doesn't equal 10. Wow, my brain is melting right at the moment. And I know you probably see the solution, and I just am too dim-witted right at the moment to see why it doesn't work. I'm going to redo it. I'm going to do it slowly. Let's make sure I even start. Maybe I didn't even start with the right problem. It looks like that is the given problem. 0.2g plus 8. Oh no. Nope. I got to isolate first. Divided by 2. Divided by 2. 0.2g plus 8 equals 5. That's the absolute value. We divided both sides by 2. So we're going to get plus or minus that. So if we subtract 8, 0.2g equals -3, right? -8 and +5, and divide by 0.2. Divide by 0.2. There are 5 of those in each. So g equals -15. So when I plug it in to 0.2 times -15, oh, negative, hello, dummy. That's why I didn't make it negative. Gah. So that makes -3 plus 8. And then, 10 equals 10. Found my mistake. Thank you for being patient. Absolute value of 5 is 5. 2 times 5 is 10. 10 equals 10. So -15 is a solution. Wow, that was really, really long coming and not very good about finding my mistake. But thanks for being patient. I appreciate it. Those two solutions do work, 65 and -65 and -15. Sorry for that big detour. Let's do number 6. Let's get on a fresh start, shall we? That's 27. We're going to divide by 3. We get 2x plus 5 equals 9. Absolute value. It's a long day. It's the end of the day. Mr. Mac's a little tired. No excuses. No excuses. Just get it done, Mr. Mac. 2x plus 5 equals 9. And 2x plus 5 equals -9. Minus 5 minus 5. 2x equals 4. Divide by 2. Divide by 2. X equals 2. That's one solution. Minus 5 minus 5. 2x equals -14. Divide by 2. Divide by 2. X equals -7. Let's test the solutions. We're going to stick with it. 2. So this 2 times 2 is 4 plus 5 is 9. Absolute value of 9 is 9 times 3 is 27 plus 10 equals 37. That's good. And my other solution is -7. -7. So if we plug in -7, so 2 times -7 is -14 plus 5 is -9. And that's negative. Ooh, almost made a mistake. Let's do the absolute value of -9, which is 9. And we get 27 plus 10, which equals 37. This is not going to be one of my better videos. Sorry. All right. Here's a good one. A machine should fill a bag with 50 pounds of sand. So that's going to be my middle. The actual mass is allowed to vary up to 2 ounces. So it can vary 2 ounces this way, or it can vary this way, 2 ounces. So we know that it can actually equal 49 pounds. 2 ounces is 14 ounces, or it can be 50 pounds, 2 ounces. So if that vary, should be plus or minus that way. So this is our minimum. That's our maximum values. Write and solve an absolute value equation and find the minimum and maximum. So how do we write an absolute value? Well, this needs to equal my variance. So it's going to be 2 ounces is going to equal this. And then it's going to be, we're going to do whatever the weight is minus 50 pounds. So that is how we are going to write that equation. 2 ounces, okay? Now, this is in, W is in pounds, this is in ounces, so I might even make this into pounds. So 2 ounces is 2/16 of a pound, which would be reduced to 1/8 of a pound. So I'd probably do that because W is in pounds, so this needs to be equal to pounds. If I had done 2, that would represent 2 pounds, and we don't have 2 pounds, it's 2 ounces. So you could have, I guess, but this is the best one. Okay, so 50 is going to be my the number that I'm going to subtract from. Okay, and that would give me 49 pounds, 14 ounces, which is that's also 49 pounds, 49 and 14/16 pounds, or 49 and 7/8 pounds would be my min, and my maximum would be 50 pounds 2/16, or 50 and 1/8 pounds. So that's going to be my max weight. Okay, and this is the weight, and then it would tell you what the acceptable variance between those would be. All right, number 8. Now we have 2 absolute values equaling each other. So the way we do that is we take the left side out and keep it as the positive value, and then we equal it to the positive and the negative of that right absolute value. So we're going to subtract 4x. We get 16x equals 16, divide by 16, x equals 1. And then we're going to distribute that negative into the parentheses. We get 20x equals negative 4x minus 16. Add 4x. 24x equals negative 16. And let's scroll down a little bit. Divide by 24. And x equals negative 8 goes into 16 twice. 8 goes into 24 3 times. So negative 2/3. Let's check the solution. So 1. So if I plug in 1, 20 times 1 is 20. Absolute value of 20 is 20. 4 times 1 is 4. Plus 16 is 20. Absolute value of 20 is 20. So 1 worked. Let's plug in, what was it, negative 2/3. Negative 2/3 is going to give me negative 2/3. So that's negative 40/3. Absolute value negative 40/3 is 40/3. And negative 2/3 gives me negative 8/3. 16 into thirds is 48/3. So if we subtract 8 from 48, we get 40/3, and the absolute value of 40/3 is 40/3. So negative 2/3 also is a solution. So I'll write it in my solution set. All right. Again, we have 2 absolute values, so we'll do the positive of the left equaling the positive of the right, and then we'll do the positive of the left and the opposite of the right. Minus p minus p. This reminds us of the situation in 1.5.
It's a girls varsity 1 and girls varsity 2 volleyball teams. Would please report to the gym at 2:50.
2:50.
Thank you. Good luck, girls.
That means there are going to be people walking in here. All right. Well, this is the most bizarre video yet this year, so let's keep it being weird. So, like in 1.5, when we have variables on both sides and they cancel out and they produce a number statement that is false, we know that that is no solution. So there's no solution to this left side of the equation. let's look at the right side. We're going to simplify by distributing out that negative. Now we're going to move the variables. 2p plus 4 equals 2 minus 4. 2p equals negative 2, divide by 2. P equals negative 1. So let's test it. If p is negative 1, we get 3. Absolute value of 3 is 3. If p is negative 1, we get negative 3. Absolute value negative 3 is 3. That is okay. So my only solution, I have one solution to number 9. It is negative 1. Okay. Same thing, 4q plus 9 equals 2q minus 1. And 4q plus 9 equals the opposite of 2q minus 1. And here they come. Hi there, how are you? So we're going to move 2q, move 2q. We get 2q plus 9. Good luck, girls. I'll see you at the game, hopefully. 4 o'clock or earlier? Yeah, thank goodness you're leaving an hour and 15 minutes early. Oh, you're leaving. Oh, it's in a way? It's not at Mark? No, it's in a way, yeah. I won't be there. Sorry. Bye, girls. 2q equals negative 10. Divide by 2. We get q equals negative 5. That's one possible solution. 4q plus 9 equals negative 2q plus 1. Let's move the q's. 6q plus 9 equals 1 minus 9 minus 9. 6q equals negative 8. Divide both sides by 6. You get q equals negative 4/3. Notice how I'm simplifying as we go. All right, let's test the solution. So negative 5. So negative 5 makes negative 20 plus 9 is negative 11. Absolute value would be 11. Negative 5 is negative 10 minus 1 is negative 11. Absolute value negative 11 is 11. So negative 5 is a solution. Now let's plug in my other value, which is negative 4/3. Negative 4/3 is negative 16/3. 9 1/3 is 27/3. And we get 11/3. And negative 4/3 times 2 is negative 8/3. And negative 1 1/3 is negative 3/3. Negative 8 and negative 3 is negative 11/3. Absolute value would be 11/3. So negative 4/3 is the solution also. We're going to put those in numeric order. Negative 5 is more to the left than negative 4/3. Okay. Number 11. 2x minus 7 equals 2x plus 9. 2x minus 7 equals the opposite of 2x plus 9. Minus 2x minus 2x. You're left with negative 7 equals 9. That's no solution, so there is no solution coming from that left side. 2x minus 7 equals negative 2x minus 9. Add 2x. 4x minus 7 equals negative 9. Add 7. 4x equals negative 2. Whoop. Divide by 4. Divide by 4. X equals negative 1/2. Let's test that. Negative 1/2. Negative 1/2 gives me negative 1 minus 7 is negative 8. Absolute value is 8. Negative 1/2 gives me negative 1 plus 9 is 8. Absolute value is 8. So negative 1/2 is my only solution for number 11. Same thing. R plus 3/4 equals R minus 7/8. R plus 3/4 equals the opposite of R minus 7/8. Do I want to do that? Yeah. Let's multiply everything by 8. We're going to multiply everything by 8. How did I get 8? Because I looked at my denominators and I found the LCM, the least common multiple. Multiples of 4 are 4, 8, 12, 16, 20, 24, etc. Multiples of 8 are 8, 16, 24, so the most common. So 8 times r is 8r. 8 times 3/4 is 6. R times 8 is 8r. And negative 7/8 times 8 is negative 7. So that's a nice, easy way of getting rid of the variables, or of the fractions. And in this case, we're also going to get rid of the variables. It's a false statement, so it's no solution. Let's distribute. We get r plus 3/4 equals negative r plus 7/8. Almost thought that was a 5. We can do that, multiply by 8 again. You get 8r plus 6 equals negative 8r plus 7. So let's move variables. 8r. You get 16r plus 6 equals 7. Minus 6 minus 6. 16r equals 1. Divide by 16. And we get r equals 1/16. Let's test. See, 1/16. 1/16. 3/4 is 12/16. That makes 13/16. R is 1/16. 7/8 is 14/16, which gives you negative 13/16. The absolute value is 13/16. So it works. We only have one solution, which is 1/16. Number 13. Okay, notice we have a coefficient here equaling two absolute values. We can't move this coefficient, much like we did when we only had one absolute value. When we have one absolute value, we're going to get rid of those two items because it was equal to a constant. So we only have one absolute value, so we can isolate it. When we have two, like these equations that we've been doing, we can't isolate it. We just take this, again, the positive value of the left side, 0.4. Now those absolute values now become parentheses, and that's sort of the tricky part. And it's still going to equal the positive side, and 0.4 times 10h minus 5 equals the negative value of the right absolute value. We'll distribute. That is 4h minus 2 equals 6h plus 2. We'll minus 4h minus 4h. Negative 2 equals 2h plus 2. Let's minus 2. We get negative 4 equals 2h. We're going to divide both sides by 2. Negative 2 equals h. That's one possible solution. We'll go back here. We'll distribute that negative. We have 0.4 times 10h minus 5 equals negative 6h minus 2. We'll distribute the 0.4. That's going to be 4h minus 2 equals negative 6h minus 2. We'll add the h's. 10h minus 2 equals negative 2. We'll add 2 to both sides. We get 10h equals 0. Divide by 10. H equals 0. So those are the two possible solutions. We're going to go and test and see if there are any exclusions. So my first one is negative 2. Plug into negative 2, we get negative 20 minus 5 is negative 25. Absolute value of that is 25. Times 0.4 is going to be 10. And then if we plug in negative 2 is negative 12 plus 2 minus 10, absolute value is 10. They equal each other. So that is a solution. Let's test 0. 0 should be a little bit easier. So 10 times 0 is 0, which leaves us with -5. Absolute value of -5 is 5. 5 times 0.4 is 2. And 0 times 6 is 0, times 2 is 2. So that also is a solution. So both of those, -2 and 0, worked in our solutions. We are almost done. We have a couple more to do. Hopefully I can get it done before. Oh yes, here we go. Write an absolute value equation has the given solutions. So this was crazy. This was super cool. So let's take the distance. If we want the distance between those numbers, we put it on a number line. We can maybe see it a little bit easier. If we want the distance between there, that's going to be 10 spaces. This is going to be 5. So -15. So the distance is going to be 15 between those. We're going to divide it by 2, and you get 7.5. Okay? Now, the middle of that. So what is the shift? So we're going to write, so I know my absolute value, my space between those is going to be 15, so half of it. So I would go 7.5 in and 7.5 in. And where would that take me to? That would take me to -2.5, because -10, 7.5, and 7.5 would take you to 5. This is a really important number. So if I'm going to write an absolute value, that has a negative shift. The way that we represent that negative shift is we add. We do the opposite of it. So in order to get back to 0, what would get me back to 0 with a -2.5? What would get me back to 0 is a +2.5. So this is my zeroing number. I tried to explain that to a student, and it was really hard. So we want to see how to get back to that 0. That's going to bring us there. I know this doesn't equal, this is my distance. But in order to, so this is the technique. It's a really, really challenging problem. But that would be the problem that would produce solutions of -10 and 5. If we plug in -10, you get -7.5. The absolute value would give you 7.5. If you plugged in 5, 5 plus 2.5 is 7.5. The absolute value would give you 7.5. So that is going to be an example that would produce that. So let's look at this. Let's again do the distance. 1.6 minus 2.8 gives me -1.2. Divide by 2 is -0.6, and we take the absolute value, which is 0.6. So that is the wiggle to the left and to the right. That is the room for error. Now, if we look at 1.6 and 2.8, and we go in 0.6 and we go in 0.6, what would that be? Well, that would be 2.2, and this is a +2.2. So how do I negate the positive shift? Well, we write the opposite of that. So x minus 2.2, the absolute value of x minus 2.2 will equal 0.6. And again, if we plug this in to check, you get -0.6. Absolute value is 0.6. We plug in 2.8. That gives me +0.6 absolute value. So don't know if you can see the trick to that trade, but that's how we do it. We subtract the 2, take half of the absolute value of that, and that's going to be my left and right buffer. And then we have to look and find the middle between 0.6 and 2.8. Yeah, that's a fun one. It's good. 16. Without solving completely, place each equation into one of the three categories. Okay, no solution. Oh, did I already put them in there? Did I forget to take? Oh, I forgot to take those out. Sorry. Delete. Delete. Forgot to delete those. My bad. Pretend you don't see this. Pretend that you don't see that. All right, so this one. Is this going to give, whoa, is this going to give me no solution, one solution, or two solutions? Well, I would assume since that adding gives me 3, that's a positive number, and we have an absolute value equaling positive, we're going to get 2 solutions. So that's 2 solutions. Let's look at this one. If we distribute, we get 20 minus 4x. So my variables are not going to cancel out. So I'm going to assume that we get 1 solution. So that's going to be a 1 solution problem. We look here, we're going to subtract 6 because we want to isolate the absolute values. And no absolute values can equal a negative number. So that's going to be no solution. No solution. Okay, so we had 3 problems with 3 different. That's going to be 9x plus 6. That's going to be, the variables are the same, but we have a false number statement, so that's going to be no solution. Let's look at this absolute. Let's minus 1/2, minus 1/2. It can equal 0, but it's going to provide us with 1 solution because there's no negative or positive difference for my absolute distance. My distance is 0, so I'm going to actually end up with 1 solution in this absolute value. Let's add 9, we get a positive value, so we will end up with 2 solutions for that one. It's a really good question. I like that problem a lot. All right, last one. I don't know if I have enough time because I think they're all coming, but we'll do it anyway. Explain how you found your solution. Solve it. Oh yes, this is the cool one. So I wouldn't, right? You can't distribute because we can't distribute into it. We can't isolate or anything of that nature. I mean, we could add 7 and get 2 times the quantity 10 minus x equals 25 minus 3 times the absolute value of 10 minus x. Now, remember how I said look at absolute values as if they were variables. So these are the same. So that's like 2x. Well, let's not do it in that color. That's like 2x equals 25 minus 3x. X representing this idea. So if we saw that, we would add the 3x to both sides and get 5x. Well, what we can do is we can add 3 times the quantity 10 minus x, because this is just acting as a coefficient. This is a really good problem. So we get 5 times the quantity absolute value of 10 minus x equals 25. And now this feels way more familiar. So we'll divide by 5 because we want to isolate. You get the absolute value of 10 minus x equals 5. And now we can solve this. We have an absolute value equaling a positive number. And we do both. We subtract 10. Negative x equals negative 5. X equals positive 5 because I multiply both sides by negative 1. And we are going to subtract 10. Negative x equals negative 15. Multiply both sides by negative 1. X equals 15. Let's check and see if both of those work. So let's do 5 first. 10 minus 5 is 5. Absolute value of 5 is 5 times 2 is 10. 10 minus 7 gives me 3. And if we plug in 5, 10 minus 5 is 5. Absolute value, that's going to give me negative 15, 8, 3. So 5 worked. That is a good one. And let's try 15. 15. Oh, they're coming. 10 minus 15 is negative 5. Absolute value is 5 times 2 is 10 minus 7 is 3. And 10 minus 15 is negative 5. Absolute value 18 minus 15 is 3. Both of those numbers work. How I saw the quantity of 10 minus x as a single value and having a coefficient. So I moved them across the equal sign in order to combine like terms. Woo!